Fold a sheet of paper 42 times, and its thickness would exceed the distance from Earth to the Moon. Is that true? We are going to prove it, because the same rule is hiding inside a grain of wheat, a line of dominoes, a coin, and one ordinary box. 5 objects, one invisible rule. It will defeat your intuition again and again, not because the mathematics is complicated, but because your mind expects the world to add, while this part of the world multiplies. Start with this sheet of paper. It is only 0.11 millimeters thick. Fold it once and the thickness doubles. 2 layers become 4. 4 become 8, then 16. By the 7th fold, we already have 128 layers. That is where our eyes begin to lose the pattern. So now let the numbers keep folding on their own. At fold 20, the stack is about 115 meters thick. At fold 40, it reaches about 120,000 kilometers. At fold 41, about 240,000 kilometers. Still short of the Moon. Fold it just once more. At fold 42, the thickness reaches about 483,000 kilometers. That single final fold adds as much thickness as all the thickness that was already there. That is what the numbers say. Reality has another constraint. Every physical fold leaves only half as much paper available for the next one. In 2002, Brittany Gallivan folded one sheet of paper 12 times. 12 real folds were already an extraordinary achievement. Our eyes lose the pattern around fold 7. Human hands reach 12. But the rule inside the numbers never stops folding, and paper is not the only object that hides it. Now take 1 grain of wheat. It weighs only about 47.54 milligrams. Use the same rule. At every step, double the pile. 1 becomes 2. 2 become 4, then 8, then 16. At first, the change looks almost too small to matter, but keep going. Imagine a room 3 meters wide, 4 meters long, and 2.4 meters high. How many doubling steps would it take to fill that room? Only 29. By then, the pile contains about 494 million grains and weighs roughly 23.5 tons. 1 grain, 29 rounds of doubling. 1 room filled. The object changed, but the rule did not. This domino is about 0.45 inches thick. Make the first gap as small as the domino itself. Then use the same rule again. Every new gap is twice the gap before it. The first one feels insignificant, less than half an inch. But after 10 gaps, add all those spaces together. They stretch almost 12 meters across the floor, and nearly half of that entire distance comes from the final gap alone. That is the personality of doubling. For most of the journey, nothing seems dramatic. Then one late step becomes as important as almost everything that came before it. Paper, wheat. Now dominoes. 3 objects have exposed the same rule, but that rule also has a reverse side. Take an ordinary fair coin. Every flip has 2 possible results, heads or tails. Each one has a probability of 1/2. Now ask for something much more specific, heads 20 times in a row. How unlikely is that? The rule is simple. Every extra flip multiplies the remaining probability by 1/2. 1 flip gives a chance of 1/2. 2 flips reduce it to 1/4. Keep adding flips and the probability keeps shrinking. After 20 flips, there are more than 1 million possible sequences. Only 1 is heads every single time. 1 in 1 million. All 48,576. This is not a new rule. It is the same rule facing the other direction. Paper, wheat, and domino gaps keep doubling. The coin sequence keeps dividing by 2. One direction makes a quantity explode. The other makes a probability disappear. Opposite directions. The same underlying rule. Now take 1 cube-shaped box. Make every side twice as long. Will the space inside grow by only 2 times? Expand the width. Expand the length. Expand the height. Each dimension doubles. But the box is not growing in just one direction. It is growing in 3 directions at once. 2 times 2, then times 2 again. The volume becomes 8 times as large, not twice as large. The larger box can hold 8 copies of the original cube. The rule was not hiding in a long sequence this time. it was hiding inside 3 dimensions: paper, wheat, dominoes, a coin, a box. 5 objects, 1 rule. So the real question is not whether the rule works. It is why our minds keep failing to see it coming. Our intuition is comfortable with a straight line. Add a little, then add a little more. But everything we just watched grows through multiplication. 42 paper folds pass the distance to the moon. 29 wheat doublings fill a room. The final domino gap alone accounts for almost half the total distance. 20 coin flips reduce one exact sequence to roughly 1 chance in a million. A box doubles in each direction, and its volume grows 8-fold. This is a blind spot in human intuition. We are good at imagining steady change, because most changes we meet in everyday life feel gradual, but some systems compound. Compound interest can look quiet in its early years, then accelerate faster than we expect. An outbreak can look small in its early stage, then multiply across a population. Data in a growing system can expand faster than linear intuition can track. These patterns do not fool us because their rules are difficult. They fool us because the beginning looks too ordinary. 1 sheet, 1 grain, 1 gap, 1 flip, 1 box. The invisible rule is already working, long before the result looks extraordinary. So the next time something seems almost unchanged, ask one question before you trust your intuition. Is it adding or is it multiplying?